So, hi everyone, I'm Konstantinn, and I'd like to talk a bit today about how Doom works on Plan 9. So, just a quick introductory note, I'm also known as Quix or Quix. I'm a PhD student in bioinformatics at Heinrich Heine University in Düsseldorf in Germany. And my topic is visualizing pangenomes, which is essentially very large graphs. But more to the topic, I'm also a long-time Ninefront user and contributor since around 2014. I've mostly done I've done some system work, mostly on the Intel graphics driver and like fixes and improvements here and there. But mostly I've been focused on applications, so games and audio stuff primarily. I got my start porting Quake 1 and 2 and Wolfenstein 3D, and I've worked on some original stuff. Also have an Pico implementation, which I've used for a whole bunch of stuff, and People, which is like an audio editor similar to Audacity, but in a much more Plan 9-like style. So anyway, Doom. Doom is the ultimate time waster. It's one of my favorite games, and I've worked on a ton on it for Plan 9 and other platforms. But just to, for a quick recap, it was released for Microsoft DOS on IBM PC and compatibles in '93 in the US, requiring at least a 386. It was quite revolutionary at the time. It pushed the boundaries of 3D games, and its software was already kind of at the forefront of this with its previous games. And even though other studios were also making 3D games, they were definitely the ones pushing the boundaries with fast-paced 3D games. And essentially they defined the first-person shooter genre. They also popularized online play. I think they coined the term deathmatch, referring to free-for-all matches online. You also had co-op modes already back then. And they expressly allowed and encouraged modding through the file formats they used, and also licensing and other stuff. So you had tools like the Doom editing utilities on the left cropping up already, as the first public demos were appearing. And tools today basically descend all the way back to those made in the 90s on DOS. And in '97, the Linux port source code was published, which was fairly unusual at the time. It was fully in C, so unlike other previous titles like Wolfenstein 3D, which had a whole bunch of assembly in the source code release, and there's no floating point, it only does fixed point arithmetic. So as a result, it's very easy to port, and you have it running on all kinds of appliances and ridiculous platforms like PDF files or your bootloader, for instance. So just to situate kind of where Linux Doom fits in, on the left you can see the family tree of the main game releases, essentially, with Doom, Doom 2, Ultimate Doom, Final Doom, and Linux Doom over here. And on the right you can see that Linux Doom is essentially the ancestor or the basis for almost all of the source ports and also tools that are still active projects to this day, like Zendronim, for instance. And Plan 9 Doom is a direct descendant to Linux Doom. So Doom was initially ported by James Tomaszke, I hope I'm pronouncing his name right, in 2009. Unfortunately, his blog posts and repositories are defunct, and I haven't been able to find any archives online, so I couldn't compare directly what he has done. But prior to Ninefront's contribution, existing input interfaces do not handle key up events. So you only get precomposed runes. For instance, whenever you type a key. And this is a problem for Doom and other games where certain actions like firing or moving is active until you release the key. So something different was needed. Shortly after Ninefront's inception, KBDFS was released, and it's essentially, to oversimplify to the extreme. It's a file server which provides this new file defkbd, which translates raw keyboard scan codes and provides kind of these events identified by a character. So it's either like a precomposed, like a rune here, or a key down or key up event. And every event gives you the entire set of keys pressed that are still pressed at the time. So there's no possibility of stuck keys, for instance. And this is very nice for emulators and for games like Doom, for instance. So I'm really simplifying this. But anyway, Doom was imported into Ninefront shortly thereafter, already using KBDFS. And ever since, it has seen a lot of fixes and changes. So a lot of bugs were fixed, typical to DOS game ports, like assumptions about pointer size or pointer to integer conversions, evaluation order bugs as well, and other undefined behavior. We have fixed a bunch of cosmetic engine bugs. So, for instance, sound effects being played twice or not at all, or stuff like this. Things that were known from different versions of the game. We've added compatibility switches for demo playback. So demos are these demo loops which record player input and then just play it back, kind of like on game consoles like the NES, where you have a demo loop at the beginning before you press any keys. And a lot of people still today record and play back demos for speedrunning or for competitive multiplayer stuff. So it's nice to have these working. So we've also raised some of the static limits. So for instance, number of objects that are visible at any time. Maps being made today are much, much bigger. And we've made some performance improvements, which I'll mention later on. So the first compatibility switch is for a bug in Doom 2, which was later fixed in Final Doom. Lost Souls, so these flaming skulls there, they launch themselves at you, and they were supposed to bounce off of you and of walls, but there's a typo in the code that just skipped all of this, and as a result, demos recorded with the Doom 2 engine will desynchronize. So the compatibility switch just disables this behavior to allow correct playback. And the second one is about another bug, this time in Final Doom, where teleporters don't reset the player's height, essentially. Allegedly TMTNT, so Final Doom is TNT and Plutonia. Allegedly they commented out one line of code here with a comment, is this even useful? Apparently it is. So this switch just disables this this line of code. Okay, now moving on to game data. Every version of the game has its own set of files, but the way it was supposed to work back then is you have every game installed in its own directory on, on DOS, and you CD into it, and all the save games and screenshots and so on are stored there. But for Plan 9, this is not exactly what we want. Preferably, we would have, the game installed like system-wide, and then each user would have their own directory with files per version. And usually, newer source ports add a whole bunch of code to implement more configuration file options and to manage user and system directories. But instead of this, we can just use namespacing. So with a fairly simple script, we can just use like a global mount point, for instance, in the user directory in libdoom. Then we can bind game directory, user game directory on top of that with the create flag. Then on top of that, also bind the system files for the given game. By version, I mean, Doom 2 or Ultimate Doom or so on. And then we just CD into this. And as a result, every file, such as, every new file that will be created will be stored in the user directory for that specific version. So everything is nicely segregated, kind of just like this. And this idea has been implemented and shipped in the 9front distribution's launcher script. And, this is kind of what the file organization would be like. So in the user directory, you'd have a config file, which was global, but doesn't necessarily need to be if you create it in one of these directories. But anyway, and here we have files for Doom 2, Plutonia, and Ultimate Doom. And as you can see, the screenshots here in PCX format and the save games all have, they don't identify the game version just with the file name. So this is why we put them in separate directories. And then the system directories can also contain stuff like mods, which are usually fairly large files. So, better, I think, to avoid a bunch of duplication and have everything at one place. So, what are these game files? They're called WAD files, short for Where's All the Data, and you can think of them as tar files, essentially. They're uncompressed collection of concatenated files, also referred to as lumps, and they're organized into sections, also referred to as namespaces, via these empty marker lumps. So I've marked a bunch of them here. They're just zero-length, like virtual files, essentially. And then in-game lumps are looked up back to front, meaning from the end of the list of WAD files all the way to the beginning. And some of these sections are cached. So instead of looking up the start of all P lumps, for instance, the location of these P end and P start are saved. So what kind of files do we have in WADs? Well, we have music files or lumps in MUZ or MIDI format. And MUZ is a subset of MIDI. Digital sound effects stored in DMX format. We have graphics as texture patches. The textures are made up of one or more patches, just squares. Flats are textures used on ceilings and floors, and sprites is for player graphics, objects, and so on. Weapon graphics and stuff like this. You have level data, so all the lumps for every map. You have demos, color palettes, and screens, and special stuff like this. But this is basically the kind of file formats you have in there. The way these are viewed and edited since the DOS days is usually with these fairly large and graphical programs that are aim to be more or less all-in-one for convenience. So they have to handle, opening, creating, writing WAD files, and they also handle like different, like they can, for instance, play back music or sound effects, or have some, primitive map viewing or editing modes, or preview of file types, basically. And WAD-Gadget, which is created by Simon Howard, the author of, or one of the main authors of Chocolate Doom, I think, is a tool that came out very recently and is for the terminal. It kind of follows the same trend, essentially. Well, what could we do on Plan 9? Well, recall the tar file analogy. This all maps pretty nicely to just the file tree. Like the marker lumps basically delimit the start or end of a directory. And so it's very easy to, the correspondence is pretty much direct. The only caveat is that we have to also store these end markers as the synthetic files, and I'll explain why a bit later, but that's it. And once you have this, nothing else on the system, no other tool or editor has to care about the format of WAD files anymore. So, yeah, the end marker hack is necessary because, as I'll show a bit later, we have to be able to rename these to kind of override the start and the end of a section, and this is necessary for mods. So these need to be modifiable. But going back to the list of file formats, we now have basically handlers for every single one of these formats. So we have a MUS to MIDI converter, we have more than one MIDI players, we have DMX deck for the digital sound effects, we have decoder and encoder for the different types of graphics, and there's a work in progress map viewer / editor, and random scripts for like color palettes and stuff like this. And so yeah, just to illustrate the overriding the end markers, here in the main WAD, so for instance for Doom 2, you have the S section going from S start to S end, and if you want to override one of these lumps, such as this one, which is the first frame of the punch, you have to override the end of the section. So since lookups start from the end, now once all the WADs are loaded, lookups will start from here instead of here, and we'll be able to override this lump. And that's basically how mods work. Now the limitations in the vanilla engine, and this bit me just a couple days ago, is that this isn't implemented fully. So actually for flats, so the F section, it works fine. For sprites, duplicates are disallowed, so this actually does not work. You have to either modify the main WAD or just copy the entire S section, like override it that way. And for texture patches, it's completely ignored. So newer source ports fix this, and I think I'll also fix this in a short order for our port, but this is the limitations for vanilla. So as an example, and I won't go through the whole process, but here's how, for instance, we can change the sky texture. So taking some picture, we just have to resize it, crop it, rotate it. We have to, change it to CMap 8 format. Then we create a new WAD file, encode it as a Doom graphic, and put it into this WAD file, and then we can just load it, basically. No, wrong map. I think this one works. And there you go, now you have Total Glenda as the sky texture here. Alright. And just as another small example, we can also change like weapon sprites with like what I tried to show in the different listing. And here I just changed the first frame of the punch to cat clock, so you can cat punch people. So this is, it's pretty simple to do. It's very scriptable and so on. So the WADFS approach is very powerful on Plan 9. But it's also because we have full control over, all the utilities, and everything uses the same interface and so on. So moving on to maps. Maps are this collection of lumps that describe the geometry and the objects in the map, and there's also separately almost a bunch of lumps created by like a pre-processing step to pre-compute this binary space partitioning tree. And this is used for line of sight, for visibility, and a bunch of other stuff. I won't go into detail into this, but technically it's a separate step, and these are somewhat optional. But all I want to say here is that basically these correspond to two separate tools. Although usually modern map editors integrate this, the node building. When you export the map, you also build the node map. So right now, it's not included in 9front, but there is a primitive kind of map viewer called dmap. And it just, visualizes different parts of the map. There are 7 different modes. I can't even remember how to switch between them, of course. It doesn't matter. But I mean, you can visualize different parts of the map, properties of the different objects, but you cannot yet move anything around. Or modify the actual map. Still work in progress. I wouldn't do a node builder from scratch just because over the years, and it's been 30 years now, a lot of the node builders that have been made have had various bugs and limitations, so this is not as simple as it looks, but there is a project I found from a couple of years ago that might be easy to port. And as an alternative, we could just skip this whole part because it is an optimization. But whether we skip it or not, we have to write a bunch of code. So it's which approach to take is a bit debatable. So moving on to music. So the way sound works is there is a bunch of digital sound channels which each play one sound, and one music channel which where something synthesizes music from one of the MUS or MIDI files. And these are more or less independent. The DOS version originally used this DMX sound library, which both John Carmack and John Romero have expressed regrets about. But in any case, the consequence is that there is no sound music playback code in the source code release. So how could we implement this? Well, we may as well just reuse the MIDI players and most to MIDI converters and stuff and just fork an exec and RC script. And this is, in essence, all of the code that's necessary to do this. You just create a pipe, and then all this file descriptor dance here is to hook up the standard output of the script back to like this pipe. So on every frame, we just read a bunch of music samples from the pipe and mix it in with a bunch of sound effect samples and output this. So it's pretty simple. And just to illustrate one of the nice side effects, which is, so it's both simple, but it's also very easy to switch to a different music synthesis engine. So the very first one, I will showcase just a couple of them, but the very first one is Games MIDI, which is the first MIDI player that we had on Ninefront, very old one. It just does sine waves, basically, for every channel, and mixes them together. So it's pretty primitive. It works, but you know, we might want something that sounds a bit better. So here's a MIDI player with OPL3 chip synthesis. So since you're launching this script every time you change a track, all you need to do to interrupt is to close the pipe. So you can change stuff on the fly. So here's using a sound font. Oof, okay. Maybe let's demo the iconic E1M1 music. So this is with OPL3. Let's do sound font. So this is with SC55 sound font. And finally, well, okay, there's two things I'd like to showcase also. One is using a USB MIDI synthesizer. So here it's one that does Roland MT32 emulation. Just need to, does it work? Hopefully it works. Let's see. So essentially, instead of launching a player, it passes the MIDI instructions through USB to this USB sampler, which to this USB sound synthesizer, which then writes samples to a different output. I have a mixer hooked up, so this isn't receiving any samples back. So this is why I need the dev0 here. Let's see, hopefully it works. So it sounds pretty good, and you can select the sound fonts and everything, so that's nice. It does use sound font for the emulation. It's basically a Raspberry Pi. Anyway, I think you get the point. And lastly, this does receive the name of the lump you're trying to play. So you can basically just play MP3 or Opus or whatever files instead. So instead of doing any kind of like music synthesis, you can just play MP3 files. All of this works and it doesn't require any extra code. So this is the synthesizer. I was using the Serdeco TM32. Okay, so just some notes on the networking model. It's a peer-to-peer architecture where 2 to 4 players launch like independent sessions of instances of Doom. Either at the time, either through IPX or serial. The connections were externally managed, so it just set up a bunch of stuff and then launched the actual game. On Linux, we use UDP/IP. So the simplest way to get any networking going is just to port the UDP/IP bits, which is, there really isn't that much to do. You just need to announce an open port and then connect to 4 other players. You can even use a CS to look up like host names and stuff. In the source code, there is a comment about using 9p, but I'm not sure if that... I mean, we can discuss this if you have any ideas about this, but I thought UDP/IP would work in general better, also for performance. So here's a photo of a one-man LAN party I set up a couple of years ago, and I just linked up a bunch of computers, including this Pentium 3 over here. And unfortunately, while everything worked, the frame rate was really poor. And the problem is that on every frame, every player has to synchronize with every other player. So send the tick data and receive every other player's tick data. Tick being like the frame update, basically. And if they're not received in sequence, they have to be retransmitted. And there is some buffering, but very, very fast. If one of the machines, like the Pentium 3, is slow, then the game is very slow for everyone. So, especially for playing over the internet, we'll need to make a different protocol in the future. And finally, some notes on performance. So Doom runs at 35 frames per second. It has to read input, update the game simulation, the game world. It has to render a frame. It has to do color palette conversion and integer scaling from 320 by 200 pixel internal frame buffer to, like Full HD or 4K or whatever sized window. It has to also mix sound effects and music and do sample rate conversion to the dev audio format. And it has to do receive and sending and receiving stuff on the network. The biggest bottleneck here is drawing to the screen, doing the scaling, followed by the palette conversion, and then the reading in and mixing music samples. So for scaling, and I'm not sure who came up with this idea initially, but essentially we can just in the code scale pixels horizontally, and then we can use the replication flag in a lock image to scale vertically. So we draw one scan line at a time over a rect that is as big as the scale. So for instance, 4 scan lines for 4 times scale, and then draw just reuses this one scan line and replicates it like 4 times. And this is way faster than just doing this manually and uploading a huge image. Then to avoid stalling, we also much later added like a synchronous drawing with multiple buffers that are being flipped continually. And for ARM64, Sigrid also contributed the assembly version of the palette conversion stuff. So this made it quite faster on the mount reform laptop, for instance. And finally, for sound, the problem here is that we're forking an RC script, and this RC script can be doing anything. So to avoid any kind of stalling anytime we start it or try to read in music samples, this has been put in its own process. Whoops. So there is a bunch of stuff still that needs to be done. Loading lumps and wads from paths is kind of annoying still. Specifying the full path doesn't really work. There are some limits. For mouse grabbing, it might be nicer to enable some delta mode in the kernel driver instead of warping the mouse anytime it moves beyond like a rectangle in the center of the screen, which is basically how it works right now. Might be nice to add features from Boom and other source ports. To be able to load newer maps as well, but this quickly gets pretty complicated because a lot of these features are quite bonkers. So we would need better networking code. Sorry, and we would like some level generators as well in future. So we might port Chocolate Doom and maybe other source ports as well. But thanks to Sigrid and Moody's work on Nope, we have a bunch of game ports of Heretic, Hex, and Duke 3D and stuff like this. And we've come to realize that a lot of the code that we have to add for, drawing to the screen or doing sound and so on, it's kind of mostly the same across all of these ports. And the emulators, the console emulators in 9front already unify a bunch of this code into this file EUI. So we could do later probably a library or just whatever that provides some kind of framework for these ports and just does all of this, just provides all this functionality already. So in conclusion, we are Doom ready. We have a fully functional Doom port. It works on all architectures 9front has been tested on and has graphics for. Most of the utilities I've shown are included in 9front, except DMAP and also the sound font MIDI player. But yeah, and there is some work to be done, but in the end, we're just fooling around. And yeah, here's the names of two books that you might want to look into. The first one is The Story of Id Software, and up to about 10 years ago, I think. And then the second one essentially is a 400-something page book that details every single aspect of the Doom engine. And the same guy, Fabien, has a book for Wolfenstein 3D as well, and I think some arcade systems. Very cool. And there is a YouTube video that has been recorded in id Software's offices right before the release of Doom. So it's an interesting look at its development. And yeah, that's it for me. Thank you very much.
We do have a handful of questions. Does anyone here in the room have any, actually? No one? I think everyone was just overwhelmed because it was so awesome.
Yes. Thank you.
All right, first question is coming up.
This is more of a share than a question. The portability of Doom, and you had it in PDF Doom. Have you seen the TypeScript type system version of Doom that it produces one frame every 12 days?
Oh yeah, that was one. That one was insane. Yeah.
Hey Daniel, awesome work, by the way. Thanks for the demo and yeah, very inspiring. My question is about the internal frame buffer and how you move the data into DevDraw. Did you consider maybe revising or reviewing the engine itself to use the DevDraw instructions to render those pixels right in the DevDraw buffer? Because essentially what you end up here, you render it in frame buffer, then you copy those pixels into the 9p message buffer, and then once again in the kernel to the screen area, right? So you have triple copying. Or as an alternative to speed it up, maybe well, of course it will break draw term, but you can seg attach the frame buffer from the screen and render directly there. So any considerations in that area?
I'm not super familiar with the architecture of DevDraw, and I haven't deep dived into this yet. I don't know. It might be worth a try, but I don't know how much of an improvement this could actually make. I know that for Quake, Sigrid has she has an experimental branch on the Quake repo where she basically directly renders, so without any color palette like conversion, so it skips this entire step and just does RGB24 colors directly. But I'm not sure. I'm not sure how you would do this fast and well, like for scaling, for instance. If you have, like for 320 by 2200 pixels, you know, there isn't that much data to move around. But once you have like a 4K window or something, I mean, yeah, I'm not entirely sure. So I can't give you a very intelligent answer about this. But yeah, might be worth a try. I don't know.
All right, and I'm reading the question from the chat now. How bad would it be to leave the audio mixing to MixFS instead of doing it internally?
So I think we've played around with this at one point. The one reason why I did not personally want to go this way, but then MixFS, there was a bunch of changes to MixFS afterwards. But one reason is to have working volume sliders. So for music and for sound, you have separate ones inside Doom, and it is useful to have them working. So there's small problems like this, but I don't, in principle, I don't think it would be like a huge issue or anything.
All right. Looks like that's it. Nobody else is moving here. So yeah, thank you very much again. And we will make sure that you also get a tiny 3D printed Blender to you. Thank you.
Awesome, and thank you. Thanks to everyone. Thanks to Anthony also, and for your patience and rescheduling and swapping all the talks and all this. Have fun.
Thank you.